All right, welcome to the AP Calculus AB Lesson 4.5 Supplement. This is the last topic that you'll learn in the unit for Unit 4, and I want you to consider the following. Think about an object that's moving on a line, okay, and it's only going on a line, and left and right, that's it. Now we're going to talk about its velocity function, which is v of t, and also the acceleration function, a of t, okay? Now, I want to talk about these two terms today. What does it mean to be speeding up? And what does it mean to be slowing down? So when I hear the word speeding up, that means the speed is increasing. We've seen that word before, right? In this past unit. And slowing down, I want to consider this the idea that the speed is decreasing. And like I said in the earlier part of the unit, in lesson 4.4, you learned that increasing just means that the derivative is, and if you think positive, you are correct. And decreasing means that the derivative is negative. Yes. So let's use this idea to help us figure out how to determine if an object is speeding up and also if it's slowing down. Okay, so I'm going to show you how we can figure out the speeding up part. I can leave the slowing down part as an exercise for you to figure out because it's kind of the same thing. So remember how we defined speed earlier in our subject here? We said speed was defined as the absolute value of velocity. So velocity gives a numerical value with a direction. For speed, we don't care about the direction. Now, I hope you remember too that an absolute value can be written as a piecewise function. We have a positive portion, which I call v of t, and this is true when the velocity is bigger than 0. I guess I can have equal to 0 as well. But it's negative v of t when the velocity portion is less than 0. Okay? Now, we said earlier that we're talking about the derivative of speed. Okay, so we better figure out the derivative of speed. The derivative of speed, dt of speed, then becomes the derivative of that piecewise function. Well, what's the derivative of velocity? You remember back from Unit 2, the derivative of velocity is just equal to, you guessed it, acceleration. So therefore, the derivative of velocity is acceleration, and this is the case when the velocity is bigger than 0. And the derivative of negative velocity is negative acceleration, which of course is true when the derivative is less than 0. Good. Now, the question is, we've got two different scenarios or two different cases, okay? So let me say to you, let's look at case number 1. What happens if the velocity is bigger than 0? Okay, so really I'm talking about this part here, this part and this part. Well, in order for something to be defined as speeding up, what do we need to have? Well, that yellow line there says that if the velocity is bigger than 0, then also what we need to see is that the acceleration is bigger than 0. Okay, that's how we define speeding up. Now there's also a second case when I'm talking about the velocity being less than 0. By the way, I forgot the equal sign here, sorry. Okay, doesn't really matter. Here I'm going to say now, well, if the velocity is less than 0, so I'm talking about this situation here, then yes, then the acceleration in this case, or actually I should say the negative acceleration, should also be bigger than 0, because speeding up means that the derivative is positive. So once again here, I'm saying that the derivative is positive. Now, most of the times we don't write it as negative a of t. So what I can do now is divide both sides by negative 1, and now you'll get this. A of t is less than 0. So notice that the two requirements here for speeding up is this. If the velocity is bigger or equal to 0, then the acceleration also needs to be bigger or equal to 0. Yet if the velocity is less than 0, then the acceleration also has to be less than 0. Notice here that the signs for both velocity and acceleration must be the same. And that gives rise to our summary here. So, what are the requirements for an object to be speeding up? Well, we just figured it out. If v of t and a of t have the same sign, then the object is speeding up. Okay? And if v of t and a of t have different signs, and this is the one I didn't prove for you, but we can hopefully deduce this, then the object is slowing down. Okay? And I know I didn't prove that to you, you could do it, but I thought maybe with this kind of idea, if you can look through or think through this, you'll actually understand why this is true. So think of a car moving along and going forwards. Okay, I'll say forward is the positive direction, and therefore the velocity is positive. If you step on the gas, okay, so you step on the gas, your car is going faster, right? Acceleration pulls you in the direction you are moving, and therefore your speed increases. So notice this is the case where the velocity is positive, acceleration is positive, speed increases. But wait a minute, going too fast, not too good. So you start to put on the brakes. So now you are accelerating in the opposite direction, or another word is you are decelerating. Okay, so you're still going forward, but you're not going forward as fast. You're actually slowing down. So yes, you're still going forward, so the velocity is bigger than 0, but the deceleration is acceleration going in the opposite direction. That's why the sign is negative. And in this scenario, the speed decreases. Okay? Now you keep doing this until you finally stop, which is cool. You're not going to crash. But then you shift into reverse and you start moving backwards. So that idea of reverse is like negative velocity. And you're going to step on the gas because you want to reverse faster. So you're going to actually accelerate in the other direction to make it faster. So you're like decelerating again in the other direction. So in this case, notice your velocity is less than 0, but your acceleration is in the other direction as well. And that's why you're actually going faster backwards. So yes, speed increases. And then you put on the brakes again. You're like, wait a minute, that's way too fast. So then you are actually now accelerating in the other direction, the opposite direction, in the positive direction. And therefore, because you are moving in the opposite direction, but your acceleration is going the other way, you notice that they are opposite, so the speed decreases again. Okay, so opposite signs for velocity and acceleration, slowing down. Same signs, speeding up. And that's the idea of this topic. So, turn the page. I've got two examples here. I got one from the 2013 AP Calculus exam. This is just part of it. So it says here I've got a particle. It moves along a straight line. For the times between 0 and 5, the velocity is given by this ugly function. Gross, but that's okay. And the position of the particle is given by s. I don't really think I need that right now. It is known that s of 0 equals to 10. Don't even need that right now for this question because I said, is the speed of the particle increasing or decreasing at time t equals to 4? So yes, if you're thinking all I have to do is figure out the velocity at 4, and the acceleration at 4, you're right. Let's do the velocity first. Just have to plug in the number, -2 plus 4 squared plus 3 times 4 to the power of 6 over 5 minus 4 cubed. Oh, what's that? Oh boy, -2 plus 28 to the power of 6 over 5. Wow, better use a calculator for that one. I think, regardless, I think the answer is negative, but if you want a number, I got here 11.475. Definitely less than 0, so velocity is negative. Good. Okay. Is that enough to determine if it's increasing, decreasing the speed? The answer is no. We need to find the acceleration, and for this one, we have to figure out the acceleration function first. So remember that acceleration is just the derivative of velocity. The derivative of -2 is 0. We'll use power rule here, so 6/5 gets brought down to the front. I'm imagining there's some chain rule here as well, an extra 2t plus 3. I hope this is pretty straightforward for you all. and then minus 3t squared. Okay. And then here, we're going to now evaluate a of 4. So let's plug in 4. 2 times 4 is 8. This is 11. What's this? I'll calculate it. I'll tell you what it is, because I'm sure you don't want to do this. It's also negative. Okay? So velocity is negative, acceleration is negative. Is the particle speeding up or slowing down? I hope you can now say that at time t equals to 4, the speed of the particle is, you got it, increasing. How come? Since both the velocity at 4 and the acceleration at 4 have the same sign. And if you'll be specific, both negative. Okay? And that's how you give a reason for your answer. So don't just tell me it's increasing. Here is the reason why. Okay? So once again, speeding up, slowing down, you need both things. You need velocity, you need acceleration, and then you just have to figure out where the signs are the same, that's speeding up, where they are opposites, it's slowing down. So with that knowledge, see if you can try now example number 2 on your own. I will hopefully do this for you as well, but I would really want you to do it yourself first and then come back perhaps and double check your answer. So I'm going to ask you to please press pause and then come back after you're done to then unpause to check the answer. Okay? Press pause. Told you to press pause. Okay, here's the answer. I hope you can find the velocity. Do that first. I'll speed this up so you'll have a nice long video to watch. Set the velocity equal to 0. Factor out the 3. Do some more factoring. And hopefully you'll see that t equals to 5 and t equals to negative 1. Okay? Looking good. And if you actually start doing a velocity number line, that's great. Kind of like how we did number lines for the previous lessons in this unit. I'll plot negative 1 and 5. And then if you did this properly, you should have found this as positive. The region between negative 1 and 5 is negative, and then here is positive. Okay? Got that? Give yourself a pat on the back right now. Let's keep going, because the next thing you do is the acceleration, which is just 6t minus 12. I'll set that equal to 0. Solve. And you should have found that t equals to 2. So I'm going to now draw my acceleration number line. I'm going to do it right underneath the velocity one. I'm going to plot 2 in the proper position. And then if you did this, you would have found that it's negative to the left of 2 and positive to the right of 2. Okay? Now here's where it gets fun. Remember, we're looking at both velocity and acceleration. Okay? When they have the same sign, oh, look at this. That would be over here in this region. When they have the same sign, I hope you realize that it is speeding up. Is this the only place where it's also having the same sign? No. I hope you can see even in this region here, it's the same sign. Both are negative. And if you're thinking, oh, how can time be negative? You're right, time can't be negative. I should have said, stop here at 0. Forget all this stuff to the left of 0. And so now I hope you see that there are only 2 intervals where it's speeding up. That would be between 0 and 2, or the interval that's bigger than 5. And why is that the case? Because the velocity and the acceleration have the same sign. And if you're curious about slowing down, well, slowing down, Well, of course, that's where they have different signs, and the only region that I see that happening is between 2 and 5. Is that what you got? Because if it is, you should give yourself a pat on the back and give yourself a great round of applause if you can also write down a proper reason to explain it. And I hope you wrote something like this, that velocity and acceleration have different signs. All right, that's it. Go ahead and try these questions. And now you are officially done Unit